All right, today we're talking about system of linear equations and inequalities. The system of inequalities, that is. So let's first talk about the system of nonlinear equations. Well, we're still going to use the same two methods that we learned how to solve for a system of linear equations. And those two methods, one was called substitution, and the second is going to be elimination, also known as the addition method. The reason why it's called the addition method because to eliminate after we add, so that's why the addition is coming into play here, all right? So the best way to do this is actually to just start an example and using those two methods to solve for our solutions, all right? So the first example, so example one, let's go with, let's say we're given these two equations here. X plus y is equal to 2, and y is equal to x squared minus 4. So in this case, since the y is already solved to be equal to itself, what we're going to do is, I'm going to make that red, all right? So what we're going to do is that we're going to substitute the second equation into the first equation. So it's going to look something like this. So I'm going to have x plus parentheses x squared minus 4 is equal to 2, okay? And anytime you do substitution, you should always put it in parentheses, just in case if this right here, the sign in front of it was a negative, we would have to then distribute that negative through before we get rid of the parentheses. So parentheses is always a good thing to have just in case, okay? So since there's nothing to distribute through or a 1 to distribute through, then we still have the same thing, all right? So, and I see an x squared and an equal sign. So anytime I see an x squared and an equal sign, I think quadratic equations, so I want to get everything to one side. So first, I'm going to just pretend that I distribute a 1 through to get rid of the parentheses. Nope. Sorry, that's clearly a 2. And then I think, ooh, I need the quadratic equation, so I want to bring everything to one side, and I want the x squared term first. So I get x squared plus x, and then I got to subtract the 2 over, and that's equal to 0, okay? So now that I have quadratic equations, I actually have 3 methods I can use to solve this. One is the AC method, as you guys learned earlier, and then the other 2 we just learned, which is one is completing the square, and the third is the quadratic formula. So if you didn't do well with factoring, I say work on it so that you get better at factoring, because that is going to last, throughout most of your math career. If you're not good with completing a square, you should use the completing square. I think the quadratic formula is probably the easiest as long as you remember the quadratic formula. So, or do the problem in all 3 ways so that you can see where maybe your mistakes might be, where the errors are. So that might be a good idea. So when I look at this, I can use the AC method and I can actually factor this left side. And when I factor this left side, I'm going to get x plus 3 and x minus 2 is equal to 0, okay? So I get x is equal to negative 3, x equals 2. And a lot of us tend to get to a point where we're like, oh, cool, I finished the quadratic equation, so I'm done, but you're not, because this is a system of nonlinear equations. So what we tend to do with systems of equations our question is, where does these 2 things meet? Okay, so the first equation here is a linear equation because we have an x and a y in it, and they're both to the first power. So we know we have a diagonal line of some sort. And the second one, since the y is not squared but the x is, that means we have a parabola. And we know that this parabola is smiling upward because the x squared term is positive. All right. So that is what's important in this case, okay? So now that I found my x, what I want to do is go, okay, I want to see what y value am I going to get based on the x. So let me see here. How do I want to do this? I'll put it right here. So when x is equal to -3, y is equal to 3 squared minus 4. And in fact, I'm going to write this way. 3 squared minus 4. So y is equal to 9 minus 4. So y is equal to 5. Okay, so that means this point here gives me the point -3, 5. Okay, so when x is -3, y gives me 5. What about when x equals 2? Actually, sorry about that, guys. I forgot this part. This is -3 squared. Still going to come up to be the same answer. But what if x is equal to 2? Well, y is equal to 2 squared minus 4. So y is equal to 4 minus 4. So y is equal to 0. So in this case, my point is 2, 0. All right. So those are my two answers. So let's see what this graph looks like, shall we? All right. So this graph right here looks something like this. Okay. So if you look at this, you see that the blue line is the parabola and the red line is the diagonal line. And it meets here and also meets here, which is my 2, 0 and -3, 5. That seems about right. So that is how in terms of graph-wise, that's what it would look like. In terms of solving it, this is what it would look like. So I would tell you to go ahead and do it in this way so that you can actually see the results. And then go ahead and feel free to go to Desmos. And check out, type in those two equations and see if you get the same points, okay? So I would tell you to go ahead and do it that way. It's a good way to check your own work. So I'm going to do this here. All right, just so that I can this down, insert, move this over, make it bigger, just so you can see it better. Okay, so essentially where those 2 points intersect is what I'm trying to look for, okay? All right, example 2. All right, example 2, I have y is equal to x squared minus 6x plus 7, and y squared, y, got excited, equals -x squared minus 2x plus 23. Okay, so a couple of things to think about here. The first equation, it is a parabola because the y is not squared, the x is, so it's going to be a smiling parabola because the x squared is positive. While the second equation is a parabola as well, but it's a frowny face parabola because the x squared term is negative. All right, so I'm going to go ahead and select this right here and turn this red. All right, so the thing that you have to look at is, okay, so I have y equals and y equals. Great. It made my job a lot easier because they set both to be y equals. So what I'm going to do is take the second equation and make it equal to the first equation. So here we go. It's going to be a negative, let me make this bigger here. It's going to be a negative x squared minus 2x plus 23 and have it equal to, and replace the y here, or replace the top y there to be x squared minus 6x plus 7. Okay, so now that I have the equation, I'm going to go ahead and solve for it. So first thing, I always want my largest power's coefficient to be positive. So in this case, the x squared term, I always want it to be positive. Now, if I took this x squared here and brought it to the left side, I would have a negative 2x squared, right? So if I can just take this and bring it over to the right side, then I'll have a positive 2x squared. So I think that's what I'm gonna do. So if I'm gonna bring that x squared to the right side, I'm gonna bring everything else also to the right side. And the main reason why I'm bringing everything over is because I see a square term and I'll also see an equal sign. So that calls for a quadratic equation, which is everything to one side, and then we have a zero side. So on the left side, I want this side to be 0. On the right side, if I add the x squared over, I get 2x squared. If I add the 2x, I get minus 4x. And if I bring the 23 over, I get a negative 16. Okay? So I'm going to try to factor this. I know I have a GCF. Awesome. Question is, can I factor the red, right? And the answer is yes, I can. So I got 0 is equal to 2. And this is going to factor to be a negative 4 and a positive 2. So what I will have is that x is equal to 4 and x is equal to negative 2. So now I got to find my other points. All right. So when x is equal to 4, what do I have? Now, it doesn't matter which equation you pick. It does not, okay? You can actually do it to both, and you should still get the same y value if that's the case, okay? So I'm going to stick with the x squared minus 6x plus 7. So, again, I would do 4 squared minus 6 times 4 plus 7. That's equal to y. So y is equal to 16 minus 24 plus 7. So y is going to equal to negative 1. So I have a point right here that is going to be 4, negative 1. Okay? All right. What if x was equal to negative 2? All right. So I have y equals negative 2 squared minus 6 times negative 2 plus 7. So I have y is equal to 4 plus 12 plus 7. So y is going to equal to 23. So now my other point here is going to be a negative 2 comma 23. So that would be my solution there, is those 2 points. Well, let's see what the picture looks like. Okay, so this is what my picture would look like right there. All right, it is 2 parabolas, one's smiley, one's frowny, right? And it would meet at these 2 points here. that point, and that point. All right, the negative 223 seems about right, and then the other one is 4, negative 1 seems about right as well, okay? So again, this is part of Desmos, okay? If you Google search that, you'll find Desmos graphing calculator, and you can type these two equations in as is. It'll give you two graphs, different colors, and then you can actually kind of look at where they intersect, okay? In fact, you can use your mouse and click on the point of intersection, and it will tell you what that point is. All right, so let's get to the third equation. The third one is going to say, example 3, okay? Example 3, let's see here. I got y squared is equal to x squared minus 36. And my other equation is 2y is equal to x minus 6. Okay? So when I look at these two, I would tell you, because no matter how we add or subtract, we wouldn't be able to do elimination here because we wouldn't be able to get rid of anything, right? Because we can't subtract the x squared from the x, or vice versa. We can't do it with the y squared and the y as well. So the best thing to do is doing substitution. But the question is, what do you solve for? So one of the things I look at, as I said to you guys before, is the coefficients, right? And I want one that has a coefficient of 1. And if I solve for these two over here by itself, for the x by itself, then I'm going to get a square root. And I know how much you guys love square roots as well. So in that case, I'm going to solve for this right here, okay? So again, I'm going to take this and turn it to red. And I'm going to take this and I'm going to solve for the x. So I'm going to get x by itself. So I got to bring the 6 over to the left side. So I'm going to have 2y plus 6 is equal to x. Okay? Then I want to take that and I want to plug it in to the first equation. All right? So that's going to look like this. So it's now going to look like y squared is equal to 2y plus 6 squared minus 36. Uh-oh, what does that mean? Well, that just means that I am taking the 2y plus 6, writing it out twice, and foiling it, okay? So if that's the case, then this is what's going to happen. I'm going to have y squared is equal to 4y squared plus 12y plus 12y plus 36, and then minus 36. So maybe what I should do here still is to do this for you and make that red, so just so you know that that parentheses gave you this, okay? All right, so here we would combine like terms. So I have y squared is equal to 4y squared plus 24y, and the positive and negative 36 kind of goes away. Awesome. Again, I want the square terms coefficient to be positive, so I'm going to bring everything to the right side. So now I have 0 is equal to 3y squared plus 24y. And I wouldn't have to use completing squares or quadratic equation for the quadratic formula for this, because this is an easy factoring, right? So it is 0, and my GCF is going to be 3y. What does it leave me? Y plus 8. So therefore I have y is equal to 0 and y is equal to negative 8. All right? Okay, great. So y is equal to those two numbers. Which equation should we plug it into? I would pick the second one myself, but that's just me because I don't have to square anything. All right, so when y is equal to 0, what do I have? I get 2 times y is equal to x minus 6. Okay, so let's see. I got 0 is equal to x minus 6. Bring the 6 over to the left side, so I got x is equal to positive 6. So this point right here is going to give me 6 comma 0. And when y is equal to negative 8, then I have 2 times negative 8 is equal to x minus 6. So what I have on the left side is negative 16 is equal to x minus 6. So I have to add 6 over, so x is going to equal to negative 10. So this point here is going to be negative 10 comma negative 8. There we go. All right, so those are my two equations. Graph-wise, what does that look like? So this right here is going to be a hyperbola and a line. So it's going to look something like this. Bring it down here, expand it. And there we go. So if you notice, it will cross here, which is that negative 10, negative 8. And it's going to cross right here. Huh, that's interesting. 6, 0. It works. All right. So maybe I should take this and put it over here this time, just to save a little bit of space. Actually, let's do this. Let's bring that in just a tad. There we go. All right. Let's do one more, because so far, if you guys look at this, so far we've done substitution, substitution, and substitution. Okay, so when will we use elimination? So let's take a look at that. So example 4. Okay, let's take a look at a problem that you would do elimination with. So, and what that looks like. So I got 5x squared plus 4y squared is equal to 24, while the second equation is going to be 4x squared minus 3y squared, and that's going to equal to 13. Okay? Okay, so that's the case. I'm going to have the first equation is going to be a circle, the second equation is going to be a hyperbola. All right, so this is where I would want to use elimination, because if I solve for any of the x's or y's by itself, it's going to be a square root, and it's going to be a bunch of fractions, let alone that. So let's say that and with elimination, you get to choose, do I want to cancel, eliminate that, or do I want to eliminate that, okay? Which is a decision to make. However, for me, I would decide to get rid of the y squared because one's already positive, one's already negative. I just need the number to be the same, and it seems like I can make both of them 12, okay? So the top is going to stay as a positive 12 by multiplying by 3, while the bottom, I'm going to multiply by a 4 to make it a negative 12. So positive 12, negative 12 would give me that 0, all right? All right, so what does the red equation going to look like? The red equation is going to be 15x squared plus 12y squared is equal to 72, while the blue is going to look like 16x squared minus 12y squared is equal to 52. All right, so what we want to do is add these two together. There we go. So what do I have on the left side? I get 31x squared. The positive 12y, negative 12y goes away, and it's equal to 124, I believe. 124. Then I have to divide by 31. So x squared is equal to 4. Okay, so if x squared equals 4, that means x could be plus or minus 2, because I will have to take the square root of both sides. So I got x is equal to positive and negative 2. Great. So that means I have two x's here. All right, so I got x is equal to positive 2. All right, so let's find what the y value would be. So the y value, and we got to do it for both x's here. All right, so it doesn't really matter, I guess. Let's stick with the first one. All right, so that means this is going to be 5 times 2 squared plus 4y squared is equal to 24. So here's what a mistake that people make, all right? Order operation tells me to do exponents before multiplication division. A lot of you guys try to do multiplication division of these two first and then raise it to the power, which is very, very incorrect, okay? So what does this equal to? This is going to be 5 times 4 plus 4y squared equals 24. So I have 20 plus 4y squared is equal to 24. So 4y squared is going to equal to 4. So y squared is going to equal to 1. So y is going to equal plus or minus 1. Wow. Okay, so if I put in positive 2, I get plus or minus 1. What does that tell me? That tells me that out of this one x value, I'm going to actually have two answers. All right, so my two answers are these. So when x is 2, y is positive 1. And when x is 2, y can also be negative 1. Okay, so there's my two answers. Okay, so what happens if x is equal to negative 2? Well, that would be 5 times negative 2 squared plus 4y squared equals 24. Okay, so this is still going to be 5 times 4 plus 4y squared equals 24. If you guys notice, that looks the same exact thing as to the left of them. So 20 plus 4y squared equals 24. So 4y squared is equal to 4. So that means y squared is equal to 1. So y must equal to positive negative 1. Okay, so same idea, right? One x value gave me two y values. So when x is negative 2, it can be 1 or negative 1. Okay, so in this case, I actually have 4 answers. All right, so let's take a look at what that looks like. So these two questions right here, again, the top one, the first equation is a circle, and the bottom one is a hyperbola. So it's all the way up here. There's really no good place to put it to give me some space. So it makes sense that it's actually hitting 4 different places. All right. So it actually does make sense that it hit 4 places. 1, 2, 3, 4. All right. That's why at 2, there's a positive negative 1. And at negative 2, there's a positive negative 1 as well. Okay? All right. Now, let's get into system of inequality. All right. So this is the part D. So system of inequalities. Okay. So with inequalities, you guys learned sooner or in the beginning. Inequality just talks about that there is shading going on, okay? There's a bunch of answers. And with inequalities, you're always going to have a bunch of answers. So when you do that, you usually use, less than, equal to, less than signs, greater than, equal to signs, and greater than signs, right? Okay, so let's take, for example, if I use x is less than or equal to 5, okay? This right here, what I'm going to do is this. I'm going to tell you a couple of things that this is good at right here. Not what I wanted. This right here is only good for 2 things. The first thing is, it helps me tell me if the line is going to be dotted. Actually, you know what? Let me write it this way instead. Or if the line is going to be solid. So if it's going to be solid or dotted. Okay? So that's all that's good for. What's the second thing it's good for? It's also good for testing. And it's to help me find where I might shade, okay, where all my answers are, okay. So then you go, well, what would the equation look like if it was dotted? All right, so I'm gonna do the same thing. Okay, that would work too. And that would be if, let's say, the equation is y is greater than -3, okay? So if that's the case, then that would be dotted, okay? So anytime you have equal, less than or equal to, or greater than or equal to, then it's gonna be solid. Anytime you have it without the equal, less than or greater than, then that's gonna be dotted. So dotted, put right here. Dotted means you're going to use it with the less than or the greater than, and solid is going to be less than or equal to versus greater than or equal to, okay? So anytime you have that equal sign, it's kind of like a closed circle. If you connect a bunch of closed circles together, it's going to form a line. If you connect a bunch of open circles, it's going to be a bunch of dashes, which will be your dotted line, okay? So let's take a look at what these 2 graphs look like. We know that these 2 have to be, one has to be a horizontal line and one has to be a vertical line. Question is which one's which? And I said to you guys before was that if I was to graph x equals 5, then that line is going to be vertical because I can plot a few points where the x is equal to 5, right? 1, 5, 2, 5, 3, 5, and then connect the dots, and you're going to get a vertical line, okay? Where if I graphed y equals -3, right? If I put a bunch of points where y is equal to -3, so 1, -3, 2, -3, 3, -3, well, that's going to form a horizontal line, all right? So With that being said, and I know that they have to be vertical or horizontal because there's only an X or Y in it with no squares, okay? So what does that gonna look like? Let's go with this. Whoa, not what I wanted to do. There we go. Okay. All right. So you notice that this one right here is a solid line. So what I would do after that, because again, those two inequalities are only good for if it's solid or dotted, and then to test a point to see if I would shade towards that point or away from that point, okay? So otherwise, I will just graph this, oops. I would just graph x equals 5, and I will graph y equals -3, because I know that y equals -3. I know where that line is. I know it's going to be dotted, so therefore that's the reason why this line right now is dotted. Okay. Question is which way to shade. Now, typically with these, you won't need to test anything. Okay, because if I look at this vertical line right here, all right, and I look at the other one, I know that everything on the left side of x equals 5, all those x values are going to be less than 5, right? If you notice, the 4 is going to be less than 5, 3 will be, 2 will be, 1 will be, everything will be, right? But to the right is not less than 5. So, that being said, that tells me that I would want to shade in this direction. And that would be my solution, okay? And with this one, I gotta be greater than -3, great. You should already know what's gonna be, what y values are gonna be greater than -3. Well, -2, 0, +2, those are all gonna be y values that are gonna be greater than -3. So that tells me that I'm gonna shade this upward. Okay, and again, same thing, this shaded area would be my solution. Okay, all right, let's do some harder problems here. Okay, so let's do it as if it was just a single piece here. Oh, okay, I was thinking that was something on my screen, but apparently not. So let's take a look at example here. So if I have x squared, and this is going to be, let's go this way. This was example 4. I'll call this example 5. Okay, so if I have x squared plus y squared is greater than or equal to 4. Okay? All right, so let me take a look here. I know that this is a circle. Okay? And what else do I know? I know that this is dotted. I'm sorry, solid. Okay? And then when testing comes, I'm going to have to test a point so I know where to shade. Okay? All right, so let's go. Let's go ahead and graph this, and the graph of this is going to look something like this. Okay, So it's gonna look something like this. So there's two sets of shading that can happen. One set of shading is that it could be on the inside. The other set of shading is that if it could be on the outside, okay? Question is, which one is correct? Oops. Okay, so let's take a look. So if I was gonna test, what do I mean by testing? Testing a point, so this red line or red solid line that's a circle is dividing you between one or the other team. So one team is on the inside and the other team is on the outside. Okay, so team 2 is on the outside while team 1 is on the inside, right? So you come to classroom late and you're trying to figure out which team you're on because you came in late. So what you would do is you will say, okay, what I'm gonna, and the professor's not helping. I'm not helping you whatsoever. I'm like, hey, you're late, you're gonna have to figure it out, all right? And I'm gonna tell you that the teams are uneven, so you're gonna have to figure it out, but only with one question. So what you would do is you go, okay, let me go to someone on the inside team, right? So in this area here, right? I'm gonna ask someone in this area. And let's say I ask 0, 0, right? If I go to 0, 0 and I say, hey, dude, am I on your team? And if he says, yes, you're on my team, then I would stay inside the circle. But if he was to say, no, you're not on my team, that means I must be on the other team. So I would leave the circle, and be on the outside team. Okay, so that's what testing mainly is. Okay, so that's what I'm going to do. Let's see here. Let me, oh, shoot. Okay. Probably draw one faster. But let's do it that way. Okay, so let's test. So I'm going to test the point 0, 0. Okay, if I was to test 0, 0, I'll get if I have 0 squared plus 0 squared is 0 greater than or equal to 4? And the answer is a big fat no. Okay. Now you can test other points as well. I mean, you can test 1, 1. It will still give you the same answer because 1 squared plus 1 squared is 2. 2 is not greater than 4, right? So that is a case that you can test any point on the inside. You can test any point on the outside. You can do 2, 2, right? If you put 2, 2 up here, all right, 2 squared is 4 plus 2 squared is 4. So 4 plus 4 is 8. Is that greater than or equal to 4? Absolutely it is, okay? So that way I would know exactly where to go. All right, let's try this again. Let's move this up. There we go. And then just draw. So we're testing 0, 0. Okay, so someone inside the circle. All right. So that means if that's a no, that means I'm going to shade everything on the outside. Okay, so that is how I would do that. All right. And therefore my solution is on the outside. All right, now if that answer was a yes when I'm testing, then all the shading would be on the inside. All right, one last example. Example 6. Okay, example 6 says this. Y is greater than x squared minus 3. And the second equation is 3x plus y is less than or equal to 6. Okay, so this is only good for two things. And we know that this is dotted. And this one here is going to be solid. Okay? That I know. So after that, I'm just going to graph y is equal to x squared minus 3, which I know is a parabola. In fact, it's going to be a smiley face parabola. The second one is a diagonal line because there's an x and a y, neither one bigger than a power of 1. So it brings me back to drawing a line or graphing a line. So therefore, I'm going to get y by itself. To get y by itself, I got to bring that 3 over to the other side. So I'm going to use the equation of y is equal to negative 3x plus 6. Okay? So those are the two equations I have to plot and then figure out which way it would shade for both of them. All right? So what does this graph look like? I think I misjudged the space that I needed. Okay, so this graph is going to look something like this. Okay, so if you look at this, if you look at the blue line, there is a left side and a right side. And then you see the parabola, there is within side the parabola and outside of the parabola, okay? So if we're dealing with the parabola, let's deal with that parabola first, okay? So in fact, I'm gonna do this. I'm going to make this right here blue just to make things kind of clear, okay? So if I was to do that, oh shoot, this is supposed to be dotted. Let's see here, insert pictures, recent. There we go. Delete this one. Move this one over here. I can shrink it a little bit. Okay. All right. So let's do this. So, so the dotted line is the parabola, okay? Now I'm going to test, so this is for graphing. Okay, so with the red one, I'm going to test, so look at the parabola, what can I test, okay? 0, 0 is always an easy point to test as long as it is not touching one of the lines or not touching the line that you're testing, okay? 0, 0 is always a good point. In fact, if you look at 0, 0, it's also as good of a point for the line as well, okay? So, all right, so let's take the yellow and let's test 0, 0. So we're gonna test 0, 0 for both, okay? So let's take a look at the red. Y is going to equal to 0 I'm making a lot of mistakes here. And the dotted is this. Is 0 greater than 0 squared minus 3? Okay, so 0 is 0. 0 squared is just 0 minus 3. So is 0 greater than negative 3? And the answer is yes. Okay? And if you notice that 0, 0 for the red dotted line is on the inside of that parabola. So In that case, if it's a yes, that means I stay on the inside of that parabola. Okay? All right. So now with the blue, I'm going to test 0, 0 again, but for the blue. So it's 0, and the blue was, ooh, sorry. I have to go back to the original here. So 3 times blank plus blank is less than equal to 6. So that's a question, right? So 3 times 0 plus 0 is that less than or equal to 6. So that is asking me if 0 is less than or equal to 6. And the answer again is yes. So again, 0, 0 will be to the left side, left and down of that purple line. So in this case, I would shade in, let's do it this way. Undo. I would shade in this direction. Okay. Actually, I probably shouldn't have done that. So, okay. So, what is my solution? My solution is going to be in here where everything is double shaded. So essentially my solution is everything right here. All right? All right. So it's that little tiny wedge. That is my solution. So in this case, again, what I'm going to do is determine it's dotted or solid, use the equal sign to go ahead and graph it. So after I graph it, then I go back to the original equation to test everything. Okay? Test a point that's not on the line, either on the left side or the right side of a line, inside or outside of a parabola or a circle, and then shade accordingly. And then wherever it's double shaded, that's what you want to put in. All right? If you have any questions, let me know.